अभी हम देखेंगे एक्सप्रेशन ऑफ रेट ऑफ रिएक्शन। रेट को हम कैसे एक्सप्रेस करेंगे?
स्पीड
लेट ए रिएक्शन इज गिवन ए प्लस बी प्रोड्यूस सी प्लस डी। नाउ द कॉमन एक्सप्रेशन इज रेट ऑफ रिएक्शन इक्वल। पहले भी हम बता चुके हैं टाइप्स ऑफ रेट। रेट हम टू टाइप्स, one is average rate and second one is instantaneous. So now rate of reaction equal, we can write here rate of disappearance of A or rate of disappearance of B. It stands for rate of disappearance. So now rate of disappearance of A, or we can write the rate of disappearance of B, or we can write rate of A stands for here appearance. Rate of appearance of C or equal to rate of appearance of. So now mathematically we can write the expression as rate of reaction equal minus 1 by A del by del T of concentration of A, or that is equal to minus 1 by B del by del T of concentration of B, or we can write 1 by C del by del T of concentration of C, or we can write 1 by D del by del T of concentration of. पहले भी हम बता चुके हैं here the coefficient is A, so the coefficient is taken as minus 1 by L. Here the minus sign indicates for the reactor. As the concentration of A and B both are found to be decreased with the progress of the reaction, but in case of the product there is no need for the sign here, because the concentration of the products are gradually goes on increasing here. So either since A and B का concentration घटता है तो इधर हम माइनस साइन लिया, और इधर C और D उसका concentration increase करता है, so there is no need for the sign here. So for example N2 plus 3S2 let it be produced to NH3. So now we can write the expression as rate of reaction equal to minus del by del T of concentration of N2 here, because the stoichiometric coefficient is here 1 and it is minus 1 by 3. Why? Because the coefficient here 3, stoichiometric coefficient is 3. So we write here minus 1 by 3 del by del T of hydrogen concentration, or equal to here the coefficient is 2. So now we can write 1 by 2 del by del T of concentration of LS. This is the general expression for writing the rate of the reaction, or expression of the rate of the reaction. Okay. Now come to explanation of stoichiometric coefficient. Stoichiometric coefficient हम किसको बोलेंगे? When a reaction is given as like this, A produced B. So now it is 1. So it is the stoichiometric coefficient is 1 here, and it is produced 1 mole of B. So here also the stoichiometric coefficient is 1. So let start the reaction here. At T equal to 0, let the initial concentration of A is the A naught, and the number of mole of B here, it is found to be 0 here, as the reaction has not started till now. So the initial concentration हम कितना लिया? A naught, and the final here the product concentration कितना हुआ? 0. So after t second, or also we can take after t minute, let the concentration of A is decreases. So it decreases to, let it be x mole decrease. So now the concentration of A will be A naught minus x, and the concentration of B will be x here. इधर जितना घटेगा इधर इतना ही परमिशन होगा. So इधर minus x, so now it is found to be plus x. So according to the rate expression, rate of reaction equal to decrease of concentration of A divided by time. Here decrease of concentration of A means final concentration minus initial concentration. Here the final concentration is A naught minus x minus the initial concentration, which is A naught here. So now subtract by the time taken. So here the time interval is t minus 0. Directly we can write it t. So minus x, minus a naught and a naught. It is cancelled. So now it is minus x by t. So initially हम पता चुके हैं. So rate cannot be negative. If we place a minus sign here, now it is converted to x by t. So for product here also the same expression we can write. Rate of reaction equal to increase in the concentration of B divided by time. Increase in the concentration of B means, so either also the final concentration minus initial concentration. Final concentration is x and the initial concentration is 0. So now it is x minus 0, the change in concentration of B. X minus 0 divided by time. So x minus 0 divided by t. So now it will be x by t. So here the rate of reaction both A and B are found to be same. If we are taking another reaction of different stoichiometric coefficient, let another reaction is given here 2A produced 3B. So same also. So when we are going to start the reaction here, means when the P equal to 0, let the initial concentration of A is A naught and either the concentration of B is found to be 0. After t second, or we can take t minute. So here the concentration of A is found to be A naught minus 2x. Why we take minus 2 here? Because in chemical equilibrium we have discussed already. For 1 mole, the decrease of concentration of is x. So here we take a 2 mole, so the decrease of concentration will be 2x here. And the increase in concentration of B is here, 3B. Why it is 3B? Because the stoichiometric coefficient is 3 here. For 1 mole, the increase of concentration is x mole. And for 3 mole, the increase of concentration will be again 3 mole. So according to the rate expression, rate of reaction equal to, if we are expressing it in the terms of reactant, then we can write the change in concentration means product concentration minus final concentration minus initial concentration. Final concentration is A naught minus 2x and the initial concentration is A naught here divided by the time interval. So t minus 0, that will be t again. So here cancelling A naught and A naught, it will be minus 2x by t. Again also from starting we know that rate of reaction is always positive. So we have to put a negative sign here. So minus of minus 2x, it will be 2x by t. For product, similarly we can write rate of reaction equal to, that is increase in the concentration of a product divided by time. Increase in the concentration of product means, that is final concentration of a product minus initial concentration of product. So now it is 3x, final concentration. Initial concentration is 0. So 3x minus 0 divided by time interval, that is t. So now it will be 3x by t. So here the rate expression is written as rate of reaction equal to, that is 2x by t, that is in terms of reactant, and for product it will be 3x by t. So now from this equation we observe that the rate expression is found to be different. Means initially we know that the rate of reaction should be kinetically same. Means the increase in concentration of product should be equal to the decrease in concentration of reactant. So in order to get equal rate here, if we put 1 by 2 here, so now 2 and 2 cancel, the expression is x by t. If we are put 1 by 3 here, 3 and 3 cancel, it will be x by t. So the decrease in concentration of reactant is increase in concentration of the product in terms of rate. So now the rate of expression is written now, or rate of reaction equal to. We can write 1 by 2 here for this expression. 1 by 2 rate of disappearance of A equal to 1 by 3 rate of appearance of B. So this is the explanation for stoichiometric coefficient. So the stoichiometric coefficient here in the rate expression is expressed as reciprocal of the rate of disappearance or rate of appearance. Okay. Now let us solve some numericals here. The question is given in 2 of 5. Decomposes to give in 2 of 4 plus half of 4. If the initial pressure is 125 mm and the pressure after 25 minutes is 150 mm, find the rate of reaction in terms of atm into second inverse. पहले भी हम बता चुके हैं रेट का 2 यूनिट है. One is atm into second inverse and another is mole into liter inverse into second inverse. So here the question is given rate in the terms of atm into second inverse. So now let us start solution here. N2 of 5 decomposes N2 of 4 plus half of at t equal to 0 means when we are going to start the reaction we have pressure of N2 of 5 is 125 mm. Here in the question it is given initial pressure means when the reaction has not started. So only we have the reactant here. So initial pressure is 125 mm. Here it is 0 and it is also 0. After 25 minutes, then some moles of it is found to be decreased. If the number of moles decrease, then the pressure will be decreased. So here the pressure will be 125 minus P. Here the P is decrease of pressure here. So now it will be P and it will be P by 2. Why it is P by 2? Initially we have discussed. Here it is 1 by 2 mole. So here 1 by 2 into P means for 1 mole the decrease of pressure is P and for half mole the decrease of pressure will be P by 2 here. So total pressure equal to total pressure means pressure of the reactant plus pressure of the product because the reaction has not completed till now. If the reaction is complete, here the pressure will be 0 here in case of reactant. But here according to the question given, after 25 minutes we are analyzing the pressure. So after 25 minutes, the pressure of N2 of 5 will be 125 minus P, pressure of this will be P and pressure of oxygen will be P by 2. So here 125 minus P, pressure of reactant and it is P and for this it is P by 2. That is minus P plus P cancel. It will be 125 plus P by 2. So this is the total pressure after 25 minutes. But according to the question given, the total pressure is 150 mm. So according to the question, 125 plus P by 2 equal to 150 here. So P equal to, solve for P. Let it be P here, 8 cm. After solving P for, let the P will be 8 cm. But in the question, we have to find out in the terms of ATM. Then X mm will be X by 760 mm ATM. 1 ATM equal to 760 mm. So X mm equal to X by 760 ATM. So now rate of reaction equal to. We know that rate of reaction equal to decrease in pressure by time. Or we can write increase in pressure divided by time. For either if we are expressing it in the terms of reactant. So now we write it here decrease in pressure divided by the time interval. So now that is del P by del P here. So del P here that is the P. P here X by 760. So now it will be X by 760 divided by time interval. Time interval is here 25 minutes. It is 25 minutes. But we have to find out in second. That is 25 into second into 60. That is X by 760 into 1 by 25 into 1 by 60. That will be the answer later Y and the unit will be here ATM into second. If the same question is given in terms of mole, liter inverse, second inverse, then how will we solve here? Before we have discussed the relation between these two, R, O, or we can directly write RP. RP means here rate in terms of pressure. That will be rate in terms of concentration into RP here. So RP, here we get here Y. RC into R. R is the universal gas constant, whose value is found to be 0.0821 into temperature. Temperature should be Kelvin scale. In the same question, temperature is not given. If the question is asked in terms of mole into liter inverse into second inverse, then compulsory the temperature should be given in the question. So here, let the question is, and inserting I am here, at 27 degrees centigrade. At 27 degrees centigrade means it will be 300 Kelvin. So here, find out RC. RC means rate in terms of concentration. Clear? Now come to another numerical tool. Question is given, same question. N2O5 decompose N2O4 plus half O. The rate of appearance of N2O4 is 1.5 into 10 to the power minus 2 gram liter inverse second inverse. Find the rate of appearance of O2 and disappearance of N2O4. So now come to solution. So rate of reaction equal. We know that rate of reaction can be written either in the terms of reactant or in the terms of product. So rate of reaction equal minus del by del T concentration of N2O5 equal to del by del T of concentration of N2O4 equal to, here the coefficient is 1 by 2. So 1 by 1 by 2. From the stoichiometric coefficient 1 by 1 by 2. Del by del T of O2 here. So given rate of appearance, RO means rate of appearance. Rate of appearance of N2O4, that is mathematically del by del T of N2O5 concentration equal to, that is N2O4 appearance. So N2O4 concentration equal to 1.5 10 to the power minus 2 gram into liter inverse into second inverse. But actually हमको रेट कौन सा टर्म में चाहिए, मोल के टर्म में चाहिए. So now we have to convert it into the terms of mole. How we can convert here? That is 1.5 into 10 to the power minus 2. We know that weight by molecular mass, that is mole. So here we have to divide the molecular mass of N2O4. So molecular mass of N2O4, that is 2 into nitrogen का atomic weight 40 into 4 oxygen. Atomic weight of oxygen is 60. So here it is 4 oxygen, means 4 into 60. So now it will be mole, liter inverse, and it is second inverse. So now come to our problem here. So we have to find out rate of appearance of O2. So rate of appearance of O2 पाने के लिए हमको वो दो को कंपेयर करना पड़ेगा. Here it is given concentration of N2O4 and we have to find out the concentration of O2 here. So now we can write now 2 into, so here 2 will be 1 by 1 by 2, that will be 2 here. So 2 into del by del T of concentration of O2 equal to del by del T of concentration of N2O4. So now del by del T of concentration of O2, it is the rate of appearance of O2 here. Rate of appearance means del by del T of concentration of O2 equal to, here this 2 is taken to this side. So it will be 1 by 2. Del by del T of concentration of N2O4. It is 1.5 into 10 to the power minus 2 divided by. Now adding this, it is 28 plus 64. 28 plus 64. It will be 94. Mole, liter inverse, second inverse. This is the rate of appearance of O2. Then we have to find out the rate of disappearance of N2O. So उसका disappearance पाने के लिए now we have to correlate these again del by del T concentration of N2O5 equal to del by del T concentration of N2O. Here there is no need for negative sign. Negative sign only indicates the reactants. But actually उसका value में कौन सा कुछ भी effect नहीं पड़ेगा. So here only the negative sign indicates the rate of the reactant. So now it is del by del T of N2O. Del by del T of N2O for it is given here same value 1.5 into 10 to the power minus 2 divided by. This is the answer. Okay.